All right, so this chicken is trying to cross the road, and he walks and then stops and then covers half. Just keeps covering half the distance. So his first leg, where he covers half the distance across the road, how far was that?
6.
Yeah. And then the next leg.
3.
Hold on. That's supposed to be feet.
1.5. 1.75. 1.75. 0.1875.
Thank you. All right, so this is a geometric sequence where you're multiplying by 1/2 each time. And so what would the rule be?
AN minus 1 over 2.
12 parentheses.
Well, what's the first term? 6. That's okay. If you did 12, you just wouldn't need to do the n minus 1. You would just do the n. All right, and then we wanted to find the total distance this chicken has traveled. And so the first distance he traveled was 6, and then we add the 3 to that, and that's 9. And then add 1.5. That's 10.5, and then add add 0.75 is 11.25, and 11.6-ish, and 11.8. And then he's going to get half closer each time. So I got off a little bit. So if he just keeps covering half the distance, is he ever going to get there? No. And so sometimes that's kind of confusing. But if you think about like at a football game, and the team is close to the goal, and they get a penalty, and it's half the distance to the goal, and they just keep getting penalties, and it just keeps moving half the distance. They don't ever just give them the touchdown. They just keep moving closer and closer and closer.
Eventually, they'll put them at the 1.
Or the 1/2, or the 1/4, or like they just get closer and closer to. They don't ever just say, "Oh, okay, you're close enough that you get a touchdown." Yeah. He would actually need infinitely many legs. He would have to keep doing this for all eternity. That would be torture. All right, so what I'm going to do is we're going to take the formula that we talked about the last couple days to find the sum of a geometric sequence. But what we're going to do, sorry, I meant to put infinity. We're going to find the sum of the first of the infinitely many terms. So he does this forever. So it was the first thing we put was the first term in the sequence, which was 6. And then it's 1 minus r, which is 1/2 here, to the n, which in this case is infinity, over 1 minus r, which is 1/2.
So it's s to the infinity?
Yeah, that's s to the infinity. We're finding the sum of all the terms forever and ever and ever. You just keep taking half and half and half and half and half and half. Okay, so someone who has a calculator close by, put 1/2 in parentheses, and then raise it to the none, a whole bunch of none, and see what you get. What'd you get?
I can't see the exponent. I can't tell it.
It's infinity.
Oh, okay. I'm sorry.
0. So when you take a number that's less than 1, it's between 0 and 1, like 1/2 or 1/3 or 1/4 or 2/3, and you raise it to infinity, raise it to the biggest number in the entire world, it is 0. So this is the same thing as 6, and then 1 minus 0, and then that denominator stays the same. So if I want to find the sum of an infinite number of terms, an infinite sum, it's the easiest formula out of all the formulas. You just put the first term in the numerator, and then it's 1 minus the r in the denominator. And so is he going to, if he does this for all eternity, you think he's going to make it? 6 over 1 minus 1/2? He does. He makes it, finally. Oh, sorry, that's 12. All right. So I'm just going to skip number 5 and 6. It's fine. If you did them, it's okay. If not, I don't think they're that important for the grand scheme of the lesson, which is just using that infinite formula. Now, that formula only works for r's that are between 0 and 1. So like if we took an r, like if you're multiplying by 3 each time, if you raise 3 to infinity or 3 to the it's too big, your calculator can't even express it because it's infinity. So this only works when the r is between 0 and 1, and we'll write that down. So if I want to find the sum of all the terms forever and ever, I'm going to use the summation notation we haven't used in a while. And we're going to go from where I is 1 to infinity. And I'm just going to use the formula for the rule of a geometric sequence. Right? That is going to be equal to the first term divided by 1 minus r if 0 is less than r is less than 1. So only if r is fallen in between 0 and 1. If r is greater than or equal to 1, the infinite sum does not exist. It would actually be infinity. But as long as that r is between 0 and 1, you can find the value of the sum. All right, so on the notation is a little messed up on this example. I didn't realize it till after I printed. The summation notation looks a little weird. Instead of being above and below, it's to the side. And then there's accidentally an extra b here that you don't need, but we can fix it. It's fine. All right, so whenever the number up here is infinity, you're finding the infinite sum, and we need to make sure we can do it. So for A, what would you guys, just looking at the formula, what would you say R is?
0.25.
Okay, so does this one have an infinite sum? Yes. And so what we would do is just take the first term, which is 3, and put it over 1 minus R. So that's basically going to be 3 divided by 3/4, which is just going to be 4. Super easy formula to use. And remember, yeah, you're going to like B even more. So because this is an infinite sum, what is R in this case?
This is above 1.
1.25.
Yeah, so does this one have an infinite sum? No. Sweet, huh? All right, let's look at C. All right, so R in this case is 1/3. Is it going to have an infinite sum? Yes. All right, so we do 5 over 1 minus 1/3, and that's going to be 7.5. Now, I was just rushing doing your notes, and I kind of messed up on D. And I said it doesn't exist, but does it? Is this one an infinite sum they're asking you to find? It's not. Yeah, it's just the first 20. So we're going to do the old formula from the last couple of days, where we'll do the first term and multiply by 1 minus the common ratio raised to however many we're adding up, which in this case is 20, over 1 minus R. Okay, and then you can just type it in just like that. It does say to do these without a calculator. That would be kind of tough. I think they meant without doing the summation in the calculator. I don't know. But I don't want to take 1.25 and raise it to multiply it by itself 20 times. That'd be a nightmare. Yeah. All right. So let's look at, we have a couple application problems. So a child on a swing is given a big push. She travels 12 feet on the first back and forth swing, but only 5/6 as far on each successive back and forth swing. How far, total distance, did she travel before the swing stopped? So we're finding the sum of all the swings, just forever, all the swings that she's going to travel. So what would R be in this case? Yeah, so when you're figuring out this, sometimes you kind of have to ask yourself, R is going to be the amount of swing that remains, which is 5/6. All right, and then A sub 1 is going to be the first swing, so it's 12 over 1 minus 5/6, which is going to be 72 feet. All right, and then number 3 is, I don't know why anybody would ever want to do this, but once a week, Mrs. Baker makes sugar cookies. Now that's a good thing, but she starts reducing the amount of sugar she puts in her cookies. So the first week she makes the recipe, she uses 2 full cups of sugar that the recipe calls for. Each week after that, she reduces the amount of sugar by 1/3. How much sugar does she use for the cookies on the 5th week? So let's just write the rule. So the first week it's 2 cups, like she should. All right. Then we have to figure out if we're going to use 1/3 as our R or if we're going to use 2/3 as our R. What do you think?
She reduced it by 1/3.
How much of it remains each time? 2/3. So if you reduce by 1/3, then 2/3 remains each time. So the swing question says only 5/6 of the swing remains, so we use 5/6. It was reduced by 1/6. Oh, that's kind of confusing. All right, and then that's going to be raised to the n minus 1. All right, so the 5th week, we're going to put 5 in for n. All right, so on the 5th week, she only uses 0.395 cups of sugar in her cookies. Nobody's going to eat those cookies. All right, and then how much sugar does she use in total baking the cookies for half a year? So this problem is all in weeks. So how many weeks is a half of a year?
There's 52 weeks in a regular year.
26 weeks. So n is going to be 26. Are we finding the 26th term? Or are we finding the sum of 26 terms? We're finding the sum. Good job, guys. All right, so we're going to do the first week amount of sugar, 1 minus 2/3 to the 26th. Over 1 minus 2/3. Okay, so all these weeks she has used 5.9998 cups of sugar. All right, and then sugar can be bought in 1 pound, 4 pound, 10 pound, 25 pound bags. There are approximately
You got what? Yeah. 5.9.
5.99998.
Yeah, 35.
You did?
Oh, you put 2 or 12.
Where is 12?
The equation above that one.
That'll probably mess you up.
Okay, so sugar can be bought in 1 pound, 4 pound, 10 pound, and 25 pound bags. There are approximately 2 1/4 cups of sugar per pound. if Miss Baker plans to keep up this habit indefinitely, what size bag does she need? Okay, so you think so?
Yeah, she's doing it indefinitely.
Let's
Not
just
sugar is on it.
see. So a 1 pound bag has 1.25 cups. And then if you take 4 and multiply it by how many cups in a pound, that's going to be 9 cups. 10 is 22.5 cups. Ryder's saying she needs 25 cups, so
If she would just get the 25-pound bag, then she wouldn't have to buy sugar.
but then it might go bad if she's not using that much. Yeah, sugar goes
I
bad.
mean, unless you don't have any like a sealed container.
It goes bad. Baking stuff goes bad kind of fast, actually. All right. So anyway, so Mrs. Baker. Okay, so we need to find the infinite sum. What are we gonna put in the numerator?
No. This
The first term in this situation.
2.
2 cups. And the denominator is going to be 1 minus the r. So if she does this forever and ever, how many cups of sugar is she going to use? Somebody type it in. It's not as much as you would think. These cookies are going to be terrible.
I'll still use it respectively. 6.
No, you wouldn't. You would.
She only used 6 cups of sugar all in her entire life.
Well, just to make these cookies, that she keeps reducing the amount of sugar in them. So eventually, there's almost. They're disgusting. I don't even know if my dog would. No, my dog would eat anything. But yeah, that would be disgusting. No sugar and cookies. It's craziness.
They still look the same?
They probably wouldn't look the same without sugar.
Show us a cookie without sugar.
You look it up yourself. I don't